Hi, my name is Brian Prail. I'm an automotive instructor with the College of Western Idaho. Today I'm going to demonstrate a manual Evaps test with the Ford IDS. That's the Ford factory scan tool. The reason this comes into play, so say if a customer brings a vehicle in and the fuel tank is below 15% or above 85%, we can't do a manual Evaps test. So if you follow my procedure, you're still able to do that test, and I'll show you what to look for. So what we're going to do, we're going to open up our IDS, so our Ford scan tool. We're going to go to Start New Session, All Other, and you can double tap on anything that's highlighted, and it'll advance you to the next screen instead of having to go down to the little blue check mark that'll be in the bottom right-hand corner. So here it found a previous session. We can either hit the X mark to start a whole new session, or we can hit the green check and it'll go back, it'll reopen a session that we have already started. So here we're going to have all of our vehicle information. We want to make sure this is correct: our VIN, odometer, year, make, model, engine size. So to do the manual Evaps test, we're going to go to the red toolbox tab. We can double click that, and then we're going to go to data logger, double click there, and then powertrain, and then engine. So like I was saying, the double click, if I just click it once, it highlights it, and then I can come down to the blue check mark, click that, or I can double click the highlighted area. So once we get to this screen, it's going to pull up all of our different PIDs that we can choose from, and this is Ford pre-populates it for the most common kind of things to look for. Here we're not going to need to look at cylinder head temp, or we're not going to need to look at EGR. If you hover over the boxes, it's going to tell you down here below what actual sensor you're looking at. So we can, anything that's gray is what's going to be on our next screen. That's going to be a live value that we're looking at. Anything that's white is turned off. So let's see, we're going to select canister purge valve or canister vent valve. We are going to select mode. You have an option of mode or a percentage. The mode is going to let us just turn it all the 100% on or off. For this exercise, that's what we're going to want to choose. Anything with a pound sign next to it, that's a solenoid or actuator that you can command. For more of that information, refer to my other IDS videos. So here I'm just going to click off different things that I don't necessarily need to look at for my test. All right, so once you select all the PIDs that you want, you're going to come down and hit the blue check mark. It's going to advance us to the next screen. Once this screen comes up, where I start in this scenario is I want to look at my fuel tank pressure. You can look at it in PSI, you can look at it in voltage, or inches of water. I tend to like to diagnose off the voltage. So the standard voltage for Ford Evaps system that's vented to atmosphere is 2.6, 2.65 is the normal range. This value, I like to see where it's at in a static position with the vehicle not run, or the engine not running. So key on, engine off. The reason for that is now I have a static value, so this is 2.6. If this automatically drops down when I start the vehicle, then I know I have a purge valve that's probably stuck open, drawing our fuel tank our fuel tank into a vacuum. So I just started the vehicle. If we look here, our Evaps vapor management valve or canister purge valve, we're at 0 amps, so it's commanded all the way off. This is a normally closed valve or solenoid. Our fuel tank pressure is still at 2.6, so we're staying right there. To me, that tells me that that valve's not stuck open. We're going to want to wait until the vehicle goes into closed loop. Now we can see our O2 sensor switching, short-term fuel, long-term fuel trims. These are all important values when I'm doing a manual test, because I can kind of determine and diagnose if I have a stuck open canister vent valve or canister purge valve off of these values. I'll explain a little bit more of that as we go. So here I have the vapor management valve / purge valve selected. I'm going to click the pound sign over here, and then this little blue button with the finger. Now I have live control over this, so I'm going to make sure it's off by pressing the negative side. That's going to close it. The plus will open the valve. Now I'm going to come over to the canister vent, the Evaps canister vent valve. I'm going to select that. Once it's highlighted black, that's going to tell me I have control. I'm going to click the blue button again, and I'm going to command that on. So now that valve is closed. The canister vent valve is normally open to atmosphere. Now I have closed it, so the system is isolated to atmosphere, or from atmosphere. So I'm going to come back and select my vapor management valve / purge valve. Depending on manufacturer, they're going to call it different things. This valve is normally closed. So at this point, if I saw this fuel tank pressure decrease, I'm going to know I have an Evaps vapor management valve or purge valve that is stuck open. Once I command this valve open, we're going to want to pay attention to fuel tank pressure. If you notice, I'm at 200 milliamps, so that's about 10-20%. Here I'm about 30 to 40%. And if you notice, our fuel tank pressure is starting to drop, and our O2 sensors are not switching at the proper rate anymore. We also notice our fuel tank, or our short-term fuel trim, are going negative. So negative is going to mean that we are in a rich condition, correct? That's going to be removing fuel from our base fuel injection or fuel pulse width. So we're subtracting fuel. The reason this is subtracting fuel right now is we're pulling fuel vapor out of our fuel tank and out of our charcoal canister. Eventually this is going to start to switch and go back to a positive, and will create a lean condition if it's stuck, if the purge valve is stuck open for too long, because we're going to start drawing more outside air than we will air from the fuel tank. In this scenario where I'm set up, we have the canister vent closed, so we're pulling just straight raw fuel vapors out of the tank. So that's why we were in a rich condition. Here, if we see our fuel tank pressure went down to 1.6 volts, we're holding that voltage is pretty steady. We're not rapidly increasing. So to me, that tells me that this system is sealed and can maintain a vacuum. So if we come up here to our canister vent, watching this, I'm going to back up just a second first, but if we're watching this fuel tank pressure, if this bleeds up really fast and this goes back up to like 2.6, then we know we have a leak in the system. So now I still have the vapor management valve closed. So the system is isolated from the vapor management, the vapor management valve / purge valve, all the way to the canister vent. So the system is closed. Once I open this canister vent, we're going to want to watch our fuel tank pressure PID. So we're at 0.3. We're going to want to look at this bleed up rate. So now I'm going to open the canister vent, and if we see our bleed up rate, this should bleed up a little bit faster than what it's doing. So that to me tells me I probably have some dust and contamination, a slight restriction in the canister vent, or the charcoal canister may have a lot of dust in it. It bled up a little bit slow, but this would have passed a test. So I'm going to show, hopefully, I'm hoping that makes sense to everybody, what we're doing. So now what I'm going to do is I'm going to leave my canister vent open and kind of display what the system would look like if we were driving down the road and we set a Evaps leak code, like a gross Evaps leak. But if we're trying to see, like, if we had a purge valve slash vapor management valve that is stuck open all the time, I'm gonna, like I said, I'm gonna leave the canister vent open, so we're vented to atmosphere. Now I'm gonna open this vapor management valve, and if we watch as this opens, our fuel tank pressure PID, our voltage is dropping. So we know the valve has opened because we've seen a decrease in this value, this voltage has decreased. So we know our fuel tank is being pulled into some sort of vacuum at this point. If we look here, we're negative 0.24%. So we're in a rich condition, correct? Negative fuel tank trims are rich. The reason for this, like I said earlier, is we're pulling a lot of fuel vapors out of the fuel tank and any fuel vapors that have been captured in the Evaps canister. Now if you look, our short-term fuel trims, they're returning close to zero. What's happening here is we're pulling all of those fuel vapors out. Eventually this is gonna go positive if we leave it stuck open long enough. If you also notice, our O2 sensors are stuck at 1 volt, so we're kind of showing a rich condition at this point. We're also in open loop fault. I didn't see it go into that. So now we're in open loop fault, so we're at a base strategy. We probably should see this start to go back to normal. So what I'm going to do is I'm going to close the vapor management valve and let this vehicle kind of go back to a unfaulted state. If we notice here, we came back into closed loop. Now our O2s, our sensors are starting to switch back at normal. Our short-term fuel trims return close. They're switching right around zero, so we're going -4 to +4, so we're right around zero. Long terms are still at zero. Our fuel tank pressure is back to where it should be. So I'm gonna command the vapor management valve open slightly again, and I'm going to see if we can get it to do. This car sits a lot, so it does get a lot of fuel vapor in the canister, a lot of fumes, that hydrocarbons that are absorbed by the charcoal. So here again, we notice our fuel trims were in a rich condition, our -26%. Our O2 sensors went rich. Now they're starting to switch back close to zero because of fuel trims. The other thing that we can also tell with if we have a stuck closed vapor management valve, if we look at our idle intake control valve, we're at 17% right now. That should be pretty close to 40. But when we command this open, we're getting a lot of unmetered air. Oops. Go the right direction here. As we command that open, if we look at our idle air control valve, it's decreased a little bit. We could develop a rough run condition here. We can also notice, or we could develop a stall concern off of when we come off of cruise or acceleration. So if we're coming off the freeway down an on-ramp, when we get to the bottom at the light and stop, the vehicle may stall because it can't compensate for that much unmetered air. But if we look at our idle air control valve now, we're at 0.799%. It's pretty much commanding that valve completely closed to try to compensate and maintain idle for the stuck open, for the unmetered air. Oops, wrong thing, select that. So, kind of a recap, if we were to have our vapor management valve commanded off at 0, either percentage or amperage, if we have that at 0, if we came up here and closed our canister vent, that's going to be plus, switch it to the on. If our fuel tank pressure, if that drops, we know that we have a stuck open canister purge valve. It's pretty that easy. It's either mechanically stuck or electronically controlled or electronically faulted, shorted, something of that nature, commanding it open. To where this is not increasing or decreasing, I'm sorry, the fuel tank pressure is not decreasing. We know this system is, or the vapor management valve is not stuck open, but we also know that, well, actually, let me step back here for a second, how our value has gone up. It went up from 2.60, now it's increased to 2.66 volts. With the canister vent closed, we're increasing our pressure in that fuel tank, so we know we're able to, this system's able to be closed and sealed where it doesn't have a gross leak, because this value is increasing as the fuel pump's running, the fuel tank, or the fuel itself is heating up, which is going to increase the pressure in the tank. So if I open this canister vent, now our pressure dropped because we're open to atmosphere again. So if you close the canister vent and you keep the vapor management valve or the purge valve closed and that fuel tank pressure increases, then we know our system's able to be sealed and closed off. So I hope that helps, and stay tuned for some of my other videos.